If there's been one topic that has really defined the work of the tag group that I've been involved with, it's this topic of web security. So I'm really glad that Andrew asked me to come here and help put this on. We have the honor of being the beta testers for the new Slack-based system for panel moderation. So thanks also for that. So without further ado, I'm gonna hand over to Jan, who's going to introduce the topic for us.
Sweet. Can I? Oops. How do I make this happen?
No.
Do I have to do something to make the slides come up? Oh, okay, cool. There we go. Cool. So who thinks it's too early to talk about anything? Yeah, I definitely do. It's actually 1:30 a.m. my time, so it's about right. So a few nights ago, I was at a web security event, and someone said, "Oh my God, security is so tedious." So I think that's actually true, and it's not the fault of web developers. It's largely the fault of the security community. We've actually made it really easy for people to shoot themselves in the foot with security. So I think we need to make security easy by default, and today's panel is going to be largely about that. So how do people attack websites? So I think these are the two categories in my head. There's code injection attacks, like someone runs JavaScript on your page, and there's also the thing where you don't show my slides anymore. Let me try to fix that.
That's man in the middle, right?
That's man in the middle. Yeah, that was actually the illustration of the second point.
Guys,
I guess I could talk about front-end data. I don't really know anything, but the speaker notes are in the console, according to this page. Oh, maybe.
Folks, can we get the right slides?
Yeah. Let me. Okay.
There we go.
For some, that might happen again. So code injection. How many people have heard of cross-site scripting? That's a lot more than I thought. How many people remember this? Wow, that is a lot. So to summarize, last year, almost exactly a year ago, there was this beautiful, beautiful cross-site scripting attack in TweetDeck, which is a Twitter client. When people tweeted script tags with an emoji in the tweet, the script would be executed, but only if there was an emoji there. And how did this make it into a release, you might wonder? Well, this was, so I downloaded the release before and after they fixed it, and took a diff and sort of reversed it. And it was actually really interesting. Not many people talked about this. Basically what they had was a function that parsed emoji, took tweet.node value, which is the value of the tweet text, and turned the emoji into image tags. Right, and then they created a new div and set that inner HTML to the emojified value, and then did some DOM surgery to put that new div back in where the original tweet was. So it's not obvious where things went wrong because, as you can see here, this was properly escaped at some point. What happened was when they parsed the emoji and added the image tags, that actually unescaped the properly escaped HTML. And when they set new div.innerHTML to emojified, that created the cross-site scripting attack, and that's why there was all this like self-retweeting tweets going on and so forth. So you might think, okay, we're done with cross-site scripting. That was just an edge case, but actually, it's very, very prevalent. While I was writing this talk, I thought maybe I'll just find a few, for example. So not wanting to hurt anyone else, I went to my own blog, which was running the latest WordPress. And I pretended to be an attacker, and I left myself a comment. So WordPress tries to prevent cross-site scripting by only letting you have certain types of tags, like A and abbreviation and formatting and so forth. So this looks like a pretty innocuous link, right? But then I click on it, and it's some JavaScript, and it says, this is your cookies, and an attacker can use that to steal your cookies. That's because you can actually put JavaScript inside link tags, so you can set the href to JavaScript, which many of you know. So cross-site scripting is still, in 2015, pretty easy. So how do we fix it? So there's something called content security policy. Raise your hands if you know what this is. Yeah. Again, a lot of you. But tell the browser, only allow certain resource types on from certain origins on this page. And you can also say disallow inline scripts entirely. So you set it as an HTTP header, such as this. So allow image source cdn.example.com, allow scripts from self, and apis.google.com. And so now when someone tries to run evil JavaScript from aptly named evil.com, the console says, we're not going to run that. The browser says, we're not going to run that. Just throw an error in the console. Cool. So why don't people use CSP, right? It's used on Twitter and Gmail and GitHub, but not so widely as you might think. So I think the first reason is the name is kind of boring. The second reason, I don't know, because it's great. So last night we decided we're going to rename it to Bat Shield. So Bat Shield stands for Back Acronym Trustworthy Secure Helper Internet-Enabled Lightweight Defense. And I drew a quick sketch for what the AdWords ad for Bat Shield might look like, so we get more adoption. So the adoption problem was solved. If you're curious about CSP, there's a great site called csptester.io where you can run things like script source, let's try that, code.jquery.com, and nonce abc, and you can paste in some HTML, right? So here we have a div that says hello world, and then we say script source, jQuery, so we load jQuery, and then we have a div that says set the text, we have a script that says set the text of the div to I suck, which you don't want to say on your website at all. And then we have a different script that has a nonce attribute of ABC that says set the text to I am awesome. So notice the CSP header has this nonce whitelisting mechanism where you can say only run this inline script if it has the matching nonce, which is ABC. So when we run this, what do you think will happen? What will it say in that one div? How many people think it will say hello world? How many people think I will say I suck? How many people think it'll say I am awesome? Most people didn't raise their hands, but that's okay. It says I am awesome, and in fact, CSP works, and we just foiled an attack, and we are awesome. So second topic, let's prevent man-in-the-middle attacks. HTTPS everything. I think that's obvious here to everyone. But it's not obvious, it's not obvious that HTTPS adoption is where it should be. In fact, it's not. Many people don't use it. So as of last year, I noticed that Quora was still sending passwords over plain text, right? 2014. 2015, you can still find weird cases where HTTPS should be used, but it's not. So this is a little website called Google. You might have heard of it. And this is a site a page on Google that doesn't use HTTPS by default, which is google.com/ads. And you see here there's this sign-in button, which is a red flag. You should never sign in from an HTTP site, even if it's not directly sending your password, because an attacker can change the target of that invisibly to be anything. So the sign-in button isn't actually there, but because it's over an HTTP, an attacker can just inject the sign-in button, right? And if you're just a normal, naive user, you might be like, oh, I should sign in to use AdWords. So you click that button, and then the attacker can redirect you to myphishingsite.google.myevilsite.com or something. And you might not notice and type your password there and so forth. So we really want HTTPS literally everywhere. How are we going to do that? Because setting up SSL is expensive and it costs money. And usually when we run tests on people for usability of setting up SSL, it takes at least an hour, even if they're an experienced developer. For instance, DreamHost has this 20-step process, and you're like, oh, how do I generate a certificate request? Where do I copy and paste it? How do I not accidentally copy and paste my private key into the website where I'm supposed to send it to the CA? Where is that email where I confirm my domain being sent? It's a really Byzantine process in a lot of cases. So our solution is a thing called Let's Encrypt, which I'm wearing a shirt for. And Alex here works on as well. So we're going to start a CA that gives out free certificates. So this is the Oprah approach. I don't know if people in the UK know about Oprah, but she gives out a lot of cars and houses to people. And she's like, everyone gets, you get a car, everyone gets a car. But everyone gets a cert in this case, not a car. What we're also going to do is give a server package, provide a server package that automates that process of validating your domain, issuing you a certificate, setting up SSL, and automatically renewing certs. This is through a protocol called Acme, which you can check out the details for at that link. But basically the idea is certificate management doesn't have to be this manual process. We can actually just write Python Bash scripts to do all of that. So I don't know if I'm going to run through the demo because it's kind of a short presentation. Sweet. But Let's Encrypt, launching September 14th. And miscellaneous topics, most of which are things that Mike West wrote. How do we fix refers? How do we do sub-resource integrity? And so forth. I'm not actually going to go through all of these, but we're thinking about starting a conference next year called Mike by Mike West, where we just talk about things Mike West works on, and you should sign up for that. Great. Thanks.
Awesome. Thank you, Jan, for that great intro. So to discuss and to answer some of these questions that around this topic, we have this amazing panel here. So first of all, I should introduce, we've got Patrick Hamann from Financial Times. We've got Virginie from Gemalto, and also one of the members of the W3C advisory board, as well as active in the W3C web security. We've got Jan, who you just have met, also from W3C Tag with me. We've got Mike West from Google, and Alex Halderman from the Let's Encrypt initiative. So we're going to get right into the questions if they come onto the screen. Okay, I see it back here. So the first, I don't see it in front of me, but the first question we have is third-party content. It's basically about how easy it is or how difficult it is for content providers to move to HTTPS, right? So in particular around third parties, in particular around third-party content and ad networks. And Patrick, this is a topic that you and I have had many discussions about, and I thought it would be best to kind of, what's your answer to this question, or what's your comment on this question?
What's my opinion on this? Well, I mean, the first thing, the short answer is that yes, we do need change from third-party providers and advert networks. So prior to the Financial Times, I worked at The Guardian, and it is a third-party problem. I honestly don't think that moving to TLS is a technical issue, especially with Let's Encrypt. That issue is going to be solved come September, and I see it as a people and an education problem. We need to go and tackle this at the root of the cause, which is third-party. It's not necessarily just adverts, as much as I probably will do a bit of advert bashing today. It's actually all third-party in general content. We produce over 500 bits of content a day. That could, 40% of that could have a third-party script in it, a Twitter embed, a SoundCloud. All of these providers need to do this. I genuinely believe that tackling it at the root cause is the problem. So Google's initiative to penalize against SEO, I think that's amazing, but I don't think that's personally the right way to be tackling it. 30%, I'm not going to pick on Google here, but for instance, 30% of adverts served in any given minute come from Google's DoubleClick for Publishers network. They have the power to go and prevent serving non-secure assets over HTTP, or to be able to do that. We need to work with people like the IAB, the Interactive Advertising Bureau, to create guidelines in which we could enforce. We can then use CSP, for instance, to enforce these guidelines. We need to create guidelines and then make sure that the providers of these networks are adhering to them, and that's the only way we can do that. So at the Financial Times, we've created guidelines that we are now trying to send to our ad ops people and people working in the commercial department to actually say, look, if you want to serve an advert on the financialtimes.com, you have to adhere to these guidelines. And I think that's the only way we're truly going to tackle that problem.
Mike, any comment on that?
Yeah, I would generally agree with a lot of the statements that you're making. I think that it is less of a technical problem and more of a problem of will. People need to understand that moving over to HTTPS has real value, both for users and for themselves, and doing so is in their financial interests. Short term, I think there are financial reasons that folks aren't moving away. Like anecdotally, I hear that a lot of CDNs make it very difficult to move over to HTTPS because it just costs large sums of money. And people don't like giving away large sums of money for some reason. So making that easier is, I think, quite important, but also, again, less of a technical problem and more of a question of convincing folks that it is in fact the right thing to do. I do think that Google is making some moves in that direction. So if you look at DoubleClick, for instance, my vague understanding of this, and I'm a bit far away from ads, so hopefully I won't say anything that's completely wrong.
Yeah.
My vague understanding is that DoubleClick allows HTTPS for all advertisements, but there are some advertisers so basically, DoubleClick will be embedded in your page and then will embed a third-party ad. So the third-party ad comes from the server of the advertiser and not from Google servers. And we don't like proxy all of that because they want control and they want to be able to measure the fact that their ad was actually served. Because of that, we have a difficult time, or so far, we've had a difficult time making the advertisers actually move over to HTTPS, but the infrastructure is all there. So it's really a question of moving that inventory over as opposed to building the infrastructure to move it over.
Well, one of the comments in here is about HTTP2, and is HTTP2 a carrot for moving people to HTTPS? I mean, isn't the topic there about what carrots do we have? I don't see a queue, by the way, so I don't know if anybody has added themselves to the queue. All right, no, nobody's added to the queue. Okay, great. So what other, I guess, opening up to the panel, what other kind of carrots do we have for moving that can help people get over that hump, that problem?
Yeah, so I was thinking about this yesterday, and I thought, well, what if browsers just didn't show known domains that are advertisers, third-party advertisers, on third-party sites, unless they were over HTTPS?
But that's like a stick, right?
Yeah, that's more like a
the
stick.
advertiser over the head and saying,
well,
be faster, be better.
No, it's like you can show your ad if it's over HTTPS.
Yeah, but that's, well, okay. You can phrase it as a carrot, but it's still a stick, right?
Yeah, okay.
Are there any other carrots?
I think carrots, so you talked about HTTP2, and I think that is, there are significant performance enhancements that you can get by moving over to HTTP2, and HTTP2 is inextricably bound to TLS. So moving over to TLS will have significant performance advantages in the short and medium term.
Comment from Jonathan Fielding? Somebody want to throw him a mic? Come on, we're beta testing the throwable mics. Where are the throwable mics? Get that man a throwable mic. No, you got to throw it. Oh. Fail.
That's a terrible catch. So, is it possible to potentially have iframes that are isolated so that we don't care if they're on HTTP or HTTPS because they are, we've set like a flag on the iframe to say it's a special iframe so that there's no interaction and stuff?
What would the characteristics of the frame be? Because iframes are already isolated, right? They're already a separate execution context, and they're already third-party, which means they're cross-origin. You don't have direct access into them. Yeah. What do you think the properties of that would be helpful?
I think, in the interest of time, maybe let's move on to the next question, just because we got to have time. So, the next comment.
Sorry, on that point though, I think that is addressing it at the wrong point. We discussed recently about that's loosening the mixed content warnings. That is the wrong way to tackle it, personally. Yeah. All
right, one more comment. Paul Downey is on the queue, and then we're going to move on to the next question, or the next question. Paul. Oh, throw that man.
Oh. DDoS attack.
Watch out.
Hi, so I don't know if this is a non sequitur, but I think certificates are great, but how do we trust, the infrastructure they depend upon, like our machines and DNS and all the kind of things that lead to that being a thing? How do I know a certificate that I'm being given is made for the world and not just for me?
Alex.
Well, I think that's one of the fundamental questions here: is how can we build an infrastructure for security that's reliable and trustworthy? But TLS and the PKI help reduce the amount of trust we have to have in things like DNS. You trust DNS maybe at the time the certificate is issued, but then after that point, the certificate infrastructure should take care of it. The main problem that we see right now is that there are just too many CAs that are being trusted, and that's why with Let's Encrypt we're creating one more.
How do I know I trust a CA? Because if somebody gives me a machine and it says this certificate's great, I there's some sort of like layering that sort of I'm trusting everything that's about that machine. You know, the people who administered it for me or the people who made it. You know, it feels like there's some sort of like we're building sort of trust in something that's based on a lot of sand beneath it.
Do you know what? We might get onto an answer to your comment in question 3. So
Cool.
I need to move on to question 2 right now, which if we can move to that on the screen. I don't see it in front of me. So the question is about, so if I can read it out, Mozilla recently announced that they're planning to deprecate insecure HTTP, and this is their words, deprecating HTTP, which I love, which includes denying new features from sites that are served over HTTP connections. Is this a mistake? And I'm going to ask Mike to kind of lead off on answering.
Sure. So this is, for background, Mozilla certainly has moved in this direction. They announced that non-secure HTTP is something that they're deprecating, and they're doing that by denying new features, which I think is an interesting take. Google has also moved in this direction. We are looking at 2 different things. First, we're looking at removing support for particularly powerful features from HTTP origins. And second, we're looking at changing the way that we display origins in the Omnibox, in the address bar in Chrome. Currently, we display like a green lock or something that shows you this site's totally secure, which is kind of backwards, right? We should actually be showing you that this site is insecure by showing you, I don't know, a big red Eye of Sauron or something for HTTP origins. So we're exploring some UI options there in order to help users understand what the actual security characteristics are of the page they're looking at. I do think that this is another case of using sticks as opposed to carrots. If people have ideas for carrots, I would love to hear them, because carrots are really hard to find.
I thought that was a carrot.
That's not a carrot. That's a big stick. Like, we're hitting people on the head and saying, this is insecure, you shouldn't use it. So the reason that we're doing this, let's split it up. We're looking at features because particular features are incredibly powerful. Geolocation is a really good example. A geolocation API allows you to determine where a user is in the world with a great degree of precision. If you enable this API for an HTTP origin, if you give that origin permission to use this API, you're actually giving that permission to anyone that sits in between you and the internet. So a man in the middle can, for instance, inject an iframe onto every HTTP page, because again, it's HTTP, it's not authenticated, you have no idea what the data is coming from. They can inject, so if you grant maps.bing.com, for instance, the ability to use geolocation, then an attacker can inject maps.bing.com into every page that you visit, every HTTP page you visit, and then use the API in order to beacon to themselves where you actually are in the world. This isn't something that we actually want to do. Instead, when you grant a permission to an origin, we want to ensure that you're granting permission to that origin and not to anyone that sits in between you and them. So that's the reason that we're moving in that direction. And I do think it's quite important.
So what, Patrick?
Well, I think that the key point that you mentioned at the beginning, Mike, there was that it's a UI and UX problem to our users, and actually it's a trust issue, essentially. I don't think that we do a good enough job within browser vendors of displaying to the user the different things that the actual actions that may perform. The permissions API is going to open up a plethora of even more problems with this. And I think we need to focus on the UX around this. How can we convey to the user what these sites and what these permissions that you're granting them are actually going to do?
And I would suggest only that in order to do that, we have to first ensure that we're talking to the right person, right? And HTTPS is absolutely critical for that.
So we have a couple of people on the queue. Yoav? Can we get Yoav a mic? Where's Yoav? Hey. There you go.
You got to call it.
We're still working this out.
Hi. So you talked about limiting powerful features to HTTPS. I think that's the right way to go, but I think that's fundamentally different than eliminating all new features from HTTP. If you do that, if you eliminate all new features from HTTP, you are punishing developers, you are hindering adoption of these new features, and there are no actual benefits to getting these, like, you're applying pressure on the wrong people. You're applying pressure on developers, and we should get out of the mindset that developers are not applying HTTPS because they're lazy.
Yeah.
and start to apply the pressure where it should be applied. So for example, applying them on third parties by Henry Sivonen had this proposal of reducing cookie persistency over HTTP, which would apply just this pressure on the people that are on the third parties that make things hard.
Well, Jan, what do you think about that? Is it just about lazy developers?
It's definitely not just about lazy developers. Like, setting up HTTPS is legitimately a pain right now.
But that issue is going to go away here, right?
But I think, to your point, Yoav, it is certainly the case that if we remove everything from HTTP, like you can't use CSS anymore, that seems like a bridge too far, right? But there are certain APIs that it seems very reasonable to remove from HTTP. Geolocation is like the canonical example of that. So I do take a little bit of issue with the aggressiveness with which the Mozilla folks have been pushing for this, because I think we have the same goal. We basically want to get to a world where HTTPS is everywhere. I think doing so by targeting those features that are particularly problematic is an easier way, or a friendlier way of going about doing it than like stopping you from using some interesting new CSS feature.
Sorry, can I just hand, Virginia wanted to say, yeah.
Just one comment. I think that your questions are relevant, but it's also about having something to kick off the movement, I would say. And then it's a matter of progressing. So first having the infrastructure ready, then having the browser makers having a good strategy and consistent one, and then educating web developers. I think that can happen smoothly if we have a plan, a migration plan.
And so who needs to be part of that plan? Who needs to?
I think we have to collect feedbacks. We have to educate. W3C can be part of it, and having like consortium pushing for a consistent plan altogether is to be built and is to be pushed.
Yeah, I think that's...
Well, it's a collective action problem, right, to move the world to HTTPS. And so part of that has to be that we need pressure from a larger and larger set of actors to make sure that the pain points are removed, things like ads that we talked about. But look, it's 2015. We're going to be looking back years from now and wondering how it was possible that the world was still using unencrypted transport widely in 2015. The same way we might look back now at how could people have been telnetting into their servers and typing their root passwords for remote management. Right? It's going to be an embarrassment. That's how history is going to look at it. And we've got to get this done fast.
Okay. One more comment, and then I think we're going to move on to the next question. Remy, can we get Remy?
I still think that penalizing the developers is the wrong way about going.
So, Remy?
And again, I'd say, well, Remy's up here. If you have ideas about carrots, I think the browser vendors are totally interested in carrots. The fact that we haven't come up with anything is our fault, not like the fault of developers. Sorry, I'm shutting up.
So yeah, security is good. There's no question about that. You talk about Let's Encrypt will solve a lot of problems, but you talk about FTP as being kind of a bit of a joke that we were using it, but actually the barrier of entry gets raised higher and higher and higher, and it's not the web developers that are going to get penalized. We're all very savvy. It's the newcomers to the internet. The barrier of entry is like a privileged access. There are people deploying with FTP because that's all they have and that's what they know, and it works. It still works. And if we put these barriers in place, does it mean that it's only for the privileged to publish?
I think that's it.
So I think I'd say two things. First, I think the example of Telnet is more on point because we've made SSH very easy to deploy. And basically, we don't use Telnet anymore. And I think we can do the same with HTTP. I think if we can get to the point where deploying a server is, by default, something that also includes creation of a certificate, then I think we're in a much better position. And I think that's what folks like Let's Encrypt and SSLmate and a variety of others that provide easy command line tools that just, you type something in and then magically a certificate appears. That's the right way to be going.
Which is a good segue to our next question, which is about Let's Encrypt. So if we can move on to our next question up here. All right, so let's talk about Let's Encrypt a little bit. So that one question I think that we have that in the web community, right, is okay, if you make certificates that easy, then what's the value of them, right? Isn't part of the value, Alex, of a certificate some due diligence that went into the production of that certificate, to sending that certificate, right? So if I can read this up, Let's Encrypt essentially just making it possible for people to use self-signed certs, and then is a Let's Encrypt EV cert a feasible concept, and how would that work? And that question came from Andrew Betts, some guy named Andrew Betts, by the way. But Alex, what's your question?
Right. So the short answer is no to the first point. This is not at all a self-signed cert, right? This is the same kind of validation that you would get with a traditional certificate authority today. It's just been automated, and the monetary cost has been reduced to zero, which gets back to the point we just heard about is this something that's excluding people. So we want to be very inclusive and make sure that the actual cost is very low. But if you look historically at what's happened with certificate authorities, it's been a little bit of a race to the bottom, right? It used to be that a CA would call up your company and ask for legal documents and notarized letters and whatever to confirm that this was valid. But with domain validation, the style that has come to dominate, it's much easier. A simple posting a file at a URL or responding to an email with a nonce is good enough. We're going to, with Let's Encrypt, adopt something that's certainly no weaker than what traditional CA practice, what common CA practices are today. And what we're hoping to do by automating the process is pave the way to do stronger forms of verification in the future. The problem with the PKI today, though, is that your attacker can just pick whatever certificate authority he wants. So the attacker is going to go to the weakest link. So for any single CA to try to do a stronger form of verification doesn't really protect anyone. That's really the next challenge we need to solve.
And to specifically answer the question about self-sign versus DV, I'd suggest that domain verification actually verifies that the entity that is receiving the certificate has administrative control over the domain. So one of the ideas is that you use DNS for multiple locations, make sure it all resolves to the same point, verify control over that point by having a file uploaded or something along those lines. And you can talk more about the protocol if you like. That's very different, in fact, than a self-signed cert. A self-signed cert, I can create one for google.com right now and locally install that and be happy with it. The problem, of course, is that I don't actually control google.com. Verifying that I have control over that origin is an absolutely critical step in order to ensure that there is any sort of trustworthiness with regard to who I'm actually talking to.
So we have somebody on the queue. Guido? Can somebody get Guido a mic? Please stand up. Come on. Where are the mics? Remy? Oh, no.
Yeah. Hey, it works.
Yeah.
Tim Cadillac Fro there. Look at that.
So I think that it's not the same as the self-sign, which is great, but the thing we should worry about is that it might, when every site has a certificate, we might get phishing as every site seems to be more safe. My worry is that there might be a form of phishing with for example, if you have a bank, you have a certificate with the highest form of authenticity, but if you can do it automated, is there might be a way to actually somehow fake the bank site, or just change one letter in the bank's name. So that's my worry.
Sure, you can do that today, though, right? So you can. An attacker is already able to try attacks like that with.
But I think the question, the questioner's point is that you can do, you'll be able to do it, but have the appearance of security because that lock will be there, or that.
Right. So it gets to the question of what HTTPS means, right? What is it indicating to the user?
Right.
And so if it's an indicator that this is a quality site, which perhaps historically it has been because of the costs associated with deploying it, then we're diluting that indicator of quality.
And I would also suggest that we should throw away that indicator of quality. Right.
Yeah.
We should drop the lock, because the lock has no meaning other than the fact that you're talking to this origin.
Whoa, 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 whoa. Well, okay. Let's talk about that.
We should. Like, HTTP is bad. HTTP should have a big eye of Sauron, and HTTPS should have no indicator whatsoever because that's what users shouldn't have to think about it. That should be the default.
Here.
But how do you then drill down, or how do you explain to users that they can drill down to actually find out what the certificate is?
Users do not care.
Yeah.
They shouldn't have to.
I don't know if I agree with that philosophy. I think, well, I'm not here to say what I think. I'm here to moderate. Let's discuss.
What do you think?
I think we ought to move on to the next question, which is, okay, so this is about CDNs, really, and so the question is, some CDNs make implementing SSL trivial by securing the last mile, right? Last mile, but doing regular HTTP to the origin, right? Is this okay? Do we like this? And should users be informed? And if so, how? So this again comes to the issue of informing users about the security context of the that they're in.
This is it's a UI UX problem again.
So Jan, what do you think?
It's so that's a hard guarantee to make, right? Like when you see HTTPS in a browser, like today, that's not the guarantee that it's encrypted between like every data center link that your data is traveling through, right? It's just like it's encrypted from the origin's front end server to you.
Yes.
And so changing that's going to be hard, right?
And it's not really clear how we would change it, right? Because if you look at Cloudflare, which is, I assume, is the point of the question, Cloudflare will give you a free cert, which is great, and they'll do it by connecting to your origin server and then proxying content. So you'll connect to Cloudflare via an encrypted connection, an authenticated connection, and then Cloudflare will connect to the backend server via some sort of mechanism. They have interesting capabilities, like you can have a self-signed cert on your server that you hand to Cloudflare and then say, only connect if this cert, so you pin the cert. And I think that's a good direction for them to be moving so that it's connected, it's encrypted all the way through. Encrypting from the endpoint to Cloudflare is significantly better than not doing that. Because we talk about the last mile. It's a lot more than a mile, right? There's a lot of hops between you and Cloudflare, and there's a single hop between, fewer hops between Cloudflare and the origin server. So you're getting significant benefits from doing this. I think it's worthwhile.
Patrick.
Well, I mean, I mentioned it's how can we portray this to the user? I think the other point that we haven't really covered here is around, we've only mentioned CDNs, but there's other things known as open proxies or government institutions that want to points along the way, and telcos are very notorious for doing this. Sometimes they're doing it for good. They are optimizing your images or not. Do we want to allow these open proxies or not? I mean, that's the question.
They're always doing it for good.
Really?
Maybe. I don't know. Okay. Guy from Akamai?
Hey, just to point out that the HTTPS, I'm very ambivalent on the HTTPS sort of for the last mile, and I think the problem is there's no single secure, and if I have private information or banking information or credit cards or whatever, I want to know that they're encrypted all the way. But I'd also point out that it doesn't end there, like especially in the sort of modern microservices environment. Your data further travels, gets stored in places, and does not get encrypted. So I kind of like the notion of dropping the lock, actually, and that extreme. But I think it's, in my opinion, you're better off not signaling to the user than giving them the wrong signal, because the users trust that technology, this voodoo, and if you show them the lock and you told them it's secure today, and it's not really, then it's a really massive problem. So I'm concerned about putting the finger, sort of plugging one hole and getting a very bigger one on the side by doing the sort of last mile HTTPS.
Yeah, so I would agree completely that the problem is not the fact that the encryption is difficult to verify all the way through. And as you say, do I write it encrypted to the database? Who knows? SSL can't protect that. The problem, I think, is that the lock gives users expectations that simply cannot be upheld by any network or any service. And that, I think, is unfortunate.
If users are compromised as a result of someone who is doing this kind of insecure proxying through a CDN, I would start to worry about liability for that company in terms of having given a false indication of security to their customers. So it's possible that we're going to start seeing forms of regulatory pressure like that that disincentivize these insecure practices.
One more comment from Jonathan Fielding. Can we get Jonathan a He's over there. Stand up, Jonathan. There you go.
Cool. So, Cloudflare are making this really easy for people to do this. Have this problem of the last mile, but we need to be sort of educating developers, and I think Cloudflare have a place in that. We need to start educating developers that this last mile being unsecure is a problem. The question is, how do we get them and other people to start educating other developers on showing that this is a problem, that we can't have this last mile being insecure?
The other final point in this question before you move on is that the one thing that really grinds my gears is a lot of people say that it's a performance problem, the reason why they terminate on the edge and not go end to end, and let's just rule that out now. It's not a performance issue. People like Netflix, the issue we were discussing last night, Mike, it was more of a money problem. We don't use performance as a gate to stand behind.
So you got that. We need to move on beyond this question about performance for HTTPS, and I think that if everybody is if anybody is thinking that performance is still an issue, go to istlsfastyet.com and find out there. Spoiler, yes it is. Okay, so so moving on to the next question here, we've got talking about the developers, right? So how can we better surface security capabilities such as encryption through JavaScript to the front end web developers, really, right? This is a bit of a different question, a la the extensible web, right? The extensible web is a kind of concept or framework that we've been using to think about a lot of work in W3C and W3C tag. And I thought, because Virginia, you're involved in the web crypto, or have been involved in the web crypto effort, you might want to lead off on that one.
Yeah, sure. So I think that HTTPS is one way to bring some security, but after we have to take care about what's going on the client side and behind the browser, I would say. So I think that having the capability for the web developer to build their own security model with an encryption API is also something that could help. So it's not, in that case, it's not about using existing infrastructure or using certificate. It's about building your own security model. So I think it's going well. It's implemented today, and I'm just inviting you to test it. Okay. So I think that's one path and one way to go.
Build your own security model really scares me, because cryptographers don't know how to build a good security model, and I think it's a really difficult problem. Everyone can come up with good encryption mechanisms, but you can only conceive of ways to break it that you yourself could think of, right? So you think, I have built the most secure thing ever. It is awesome. I rot 13 twice, and then it's beautiful. And you'll probably come up with something better than that, but there are really smart people out there that can come up with better ways.
So what are you arguing for?
My concern is that web crypto is they are a good set of primitives. We should provide them. Yeah. But it is not the same as bootstrapping trust. So if you see what Netflix was doing a while back, they were actually using web crypto in order to pretend that they had TLS, right? They were doing encryption over HTTP and then decrypting out on the client, which did not work. Yeah, so that was one use case. That was a Netflix use case, and they actually tried to overlap the both stuff of HTTPS and encryption in their application. That's not the right way to use it, I think. And what I'm suggesting by saying please use encryption and this kind of stuff is for using your own credentials. Using it. Don't build your own cryptography, but use these tools in order to protect the credential that you are managing inside your own application. That's more the way I'm promoting it.
So we have somebody on the queue, Katie Mo.
Hi, yeah, I just want to agree with Mike's point. Don't build your own crypto, especially not in JavaScript. JavaScript does not have a proper random number generator. It doesn't have a cryptographically secure, pseudo-random source.
So I'm not actually sure that's true, right?
Yeah, I don't think
web crypto fixes that.
Yeah, web crypto was designed to fix that in part.
Okay.
But
can you talk about that?
I'll defer to you.
What do you mean by talking about that? What do you want to know exactly?
Whether or not JavaScript can actually generate the kind of random numbers you need for cryptography.
Sorry, can you?
So web crypto exposes a JavaScript API, and the RNGs in like the C++ layer.
The native, like it's allowing the browser to implement it itself. So what I'm saying is, in JavaScript, just pure JavaScript without using the web crypto API, you don't have proper random number source. Is that true?
Well, I mean, the web crypto API in the browsers that it ships in, it's exposed to JavaScript.
Yeah.
So I guess I find it difficult to
JavaScript,
understand the distinction.
Yeah.
If the browser doesn't support what is it, window.crypto.generate random number something, make a long string.
Yeah.
If it supports that, then you can use it, and that is a totally reasonable thing. If it doesn't support that, and you're just using rand or math.rand, then yeah, that's not going to help.
Yeah, I think we agree.
Yeah.
So next comment from Robert. Long throw. Excellent.
So I had it, trying to use the web crypto API in its current state. Problem I ran into is that the basic APIs, yes, they're shared, but the exact families of algorithms that are available differed somewhat between browsers, and I think on Chrome it was even different depending on like the platform you were on. So in the end, just using random numbers from the platform, it was easier to build everything. It was easier to use, say, Crypto.js or something else on top of that. What's being done to make sure that the web crypto APIs provide not just same APIs, but the same crypto algorithms, etc., across browsers?
So I think that just in terms of writing the spec, because that's part of my job, what we did is taking the minimum common among the different platform vendors, and that's a first way to be successful. Now we are more in a way of defining some profiles. That's where we are kind of stuck. So I'm not going to say that your wish is already done. That's not true. And we are just trying to work on profiles and tests.
Yeah.
So, yeah, I think the takeaway maybe is to maybe during the break to have a informal breakout on web crypto. Virginie and maybe Jan can help on that one. So I think we need to move on to the next question, unless you wanted to. Am I stepping on you?
No.
Okay. All right. Okay. So the next question is again from some guy named Andrew Betts. Often HTTPS is used to punch through middle boxes, and by middle boxes I'm talking about that's a term that we use to talk about things like intermediaries, HTTP proxies, that sort of thing. That might otherwise interfere with data that they don't understand or don't like. So this is something that definitely came up in the discussion about HTTP2 and HTTP2 negotiations. But some of these middle boxes are trying to do helpful things, right? So can the competing agendas be reconciled? Anybody want to speak to the helpful things that middle boxes can do? Okay, Al.
Sure, there are all kinds of helpful things middle boxes can do, like, I don't know, censor the internet or inject advertising. Yeah, that's another great example.
Inject scripts.
I think the middle box question. This is something that a lot of businesses are operating in the model of let's build middle boxes and sell them, and this is the proper point to be doing network management. But I just think that model is not going to survive the transition to HTTPS. And the problem is that there's no trust relationship between the user and this point in the middle of the network. The user, the person who's controlling the client, really should be able to authorize or deauthorize interference with that connection.
But don't businesses, say, big corporates, have some kind of right to be able to monitor the internet use by their employees, for instance?
I mean, if you have administrative control over a machine, then your option is to install a locally trusted root and then sign your own certs. And that is a perfectly reasonable thing for enterprises and people who exert administrative control over a machine to do. It's completely inappropriate for a random thing in between you and the thing you want to talk to exert the same level of control over your data.
So you would make a distinction between man-in-the-middle installed by your IT team versus man-in-the-middle.
I think they both have the same capability. One is legitimate, one is not.
Okay. Any other? No, you don't want to.
I've already aired my stance on this. But.
Okay, we've got Mike.
Yeah, sorry, Mike just said what I was, one of the 2 points. The other one was, in mobile browsers, it would actually be really nice to have the subject in there. So on iOS Safari, on desktop, on every system, if I have an EV cert, it shows something. On Chrome, Android, it's the only place currently that doesn't.
That's true.
Well, that gets back to the question of getting rid of the lock. I mean, I don't mean to digress on this topic for a second, but one of the things that I talk about when I talk to developers about why they should be using building applications in the browser instead of native applications, for instance, is that the user gets an indication of the secure context of the connection in a web app that they don't have when they're using
I think my point is that removing the lock is provocative. What I think I want to accomplish is to reverse the expectations of users. We show a lock because we expect the web to be insecure, and then there are these special sites that are, in fact, they have some modicum of security. And I think we should reverse that. Instead of saying, this site is special and secure, we should be saying, this site is special and terrible. Please do not go to it.
Should we expose the extent of validation of the site to the browser? In Chrome Android?
I think it is, well, I think it's an interesting conversation. I don't see any particular value in EV. I think that EV is a good way for... So there are concerns with regard to the data that's actually being displayed to users. So if you have different jurisdictions, you can have the same company or the same company name in various places. If the browser asserts that company name X with like a country code next to it is the thing that you're talking to, it's not really clear that that actually gives value to users. And if you look at like Bank of America, I think for a while it wasn't actually showing Bank of America, it was showing whatever the parent company was, or something along these lines. And I think that's that makes it difficult for me to believe that EV has any particular value. I think the value of TLS is the fact that you have an encrypted and authenticated connection to the thing that you're talking to, and you know you're talking to that origin. Knowing that somebody else really believes that that origin belongs to a company is, I don't know, maybe there's value there.
Okay, so I think one more, we got one more comment, and then I really got to move on to our last question because we're down to like 3 minutes here. So, and I know they're very strict. Andrew is really strict on time. You don't know what it's like.
Talk about carrots and sticks. Okay. Andrew is just all stick, right?
Do you have nightmares?
Sorry. Guido? Great.
So for the company I work at, we build an online service which is being used in South Africa. And the thing is, their monthly bandwidth is about 2 megabytes. So if you use a modern website, for example, SoundCloud, which if you just load the homepage, is already 2 megabytes. So the data providers use a lot of mechanisms to cut the bandwidth. For example, only load the first 4 images. And that's stuff that's really useful for them. For all of the people in South Africa, which have a 10 or 2 megabytes monthly bandwidth, just loading a modern website over there would kill the monthly bandwidth. So there is some usefulness to the third parties in between. So
yeah, I mean, I think this is one of the key cases for middle boxes, positive cases for middle boxes, which yeah. I think it's difficult to see how that.
If a user explicitly opts into that model, which I think they do with things like Opera Mini and UC Browser and a variety of these other mechanisms, if the user is opting in and understands what the impact is, and understands that there is a man in the middle that is viewing all of the data and has the ability to give them benefits for it, then that's totally legitimate. The issue that I see is with things popping up randomly in between you and them, like the NSA, for instance. Those probably shouldn't have the same level of access to the data that a trusted and intentionally installed service might have.
Yeah, +1.
Okay, we're down to 1 minute, so we have one last question that I wanted to raise.
You can read, and then
we can think about.
Put it into the room for.
So TLS is great and more secure than HTTP. All right, as we've established, but it's not perfect. Are there plans to improve or replace it in the future? So where do we go from here as far as algorithms and the kind of infrastructure stuff? Alex.
So yes, there are plans to improve it. We're looking at the TLS 1.3 protocol is being discussed right now. And there's a lot of research into the flaws in the current one. We're seeing, unfortunately, attacks happen commonly that are reducing the security of the protocol. Over the past year, we've had incidents like Poodle, like the Freak attack, like the Logjam attack that have been really breaking a large fraction of all websites. And we need to get to the point where the protocol is streamlined, there's less technical debt, so that breaks like that are less likely. And that's part of what the TLS 1.3 process is working towards. So.
Okay. Last word, Jake Archibald, you're on the queue.
Should we be doing things like HSTS? That's still coming from my server to say this must be served securely. But if the man in the middle gets there before that's sent, then I'm still screwed, right? Should this kind of security be done at a DNS level, or should there be a TLD that is always secure?
Well, I think the DNSSEC people would say something about that.
I'm sure they would.
I think.
Oh, sure. Okay. A TLD that's always secure. I kind of like that idea.
So .google just got added to the HSTS preload list in Chromium, which I think is interesting. Adam Langley, who's like the TLS guy, asked whether, so ICANN is doing all these amazing new TLDs, and if any of them would like to be HSTS only, we are more than happy to add them.
Yeah.
Okay, so we do need to get off the stage now. Thanks to the panelists, and I hope that we can. We're going to have an opportunity to discuss and expand on all this stuff in the security breakout that's happening later, so I encourage those people who are active in this discussion to join us there. Thank you very much.
Cool. Thanks.
Thanks.